Today will be the first day to review over our midterm. Some things before we get into the information is some testing tips. Number one, know how you can use your calculator. When given an equation to find the value of a variable, you can plug it in the calculator using the y equals function. Typing in your left expression, your left side, in y1, and then the right expression, the right side, into y2. Then you can go to the table and find where the x value, or find the x value where our y values are equal. If it's a decimal, you can go to the graph and use your second trace, which is a calculation option, and 5, and then press enter 3 times and find where they cross, the intersection. Testing tip 2 is to work backwards. For the most part, on tests, you'll be given multiple choice. You'll always have that opportunity to take the answer choices and plug it in for your variables. You want to see if it creates a true statement when comparing each one to know if your answer is correct. If it is a false statement, then you know that answer does not work. Now into the actual work. If you're not going to use these two test tips, we can go into the logic behind it. For example 1, it goes, what is the value of x in the equation below? And it gives us this given equation. Now if I were to use the test taking tips, the calculator tips, the 2/3 times the difference of 9x and 6 would be my y1, whereas 4x plus 10 would be my y2. Our operation, the way we would work it out, is first we would distribute to get rid of our parentheses. This is where I take my 2/3 and multiply it by 9x, and the 2/3 and multiply it by the -6. After we distribute, we get our new line of 6x minus 4 equals 4x plus 10. The next step that is not set in stone, but it sets you up in case your variable cancels out, is to move your variables to one side. In this case, to move over the 4x, I have to eliminate it from the right side. We do this by subtracting both sides by 4x. This gives me 6x minus 4x, which is the 2x. We still have the -4. Our 4x minus 4x cancels out and leaves us with the 10. From here, it's a two-step equation that we've been dealing with. We want to get rid of the constant first, our -4, by adding 4 to both sides. This is where 10 becomes 14. And then my last step is to divide both sides by 2, which gives me x equals 7. 14 divided by 2 is 7. If you use the calculator technique, you'll come up with your answer. The other option is to work backwards. You can take each one of these values and plug it into the equation and see which one will make the left expression equal the right expression. So this works well when you have multiple choice because you have a limited number of options. You only have to do it a max of 4 times. The same process is here, where I find w equals 25. I can easily plug in this as my left expression into the y1, and this into my right expression, my y2. Now with this, since it is not multiple choice, I cannot work backwards in plugging in the answer choices. I can use this step, however, to see if my answer is correct. Once I find my value of 25, I can plug it into the calculator, left expression, and then see if that value equals the right expression. If it becomes a true statement, I know I have the correct answer. Moving on to the next piece of information, we will focus on domain and range. Our first area is simply giving us definitions of what they are. Domain be including the x values, range includes the y values, and then the two different types of data that we can deal with. Discrete data, you're counting something and it is written as a set of values. Our sets will have our nice curly brackets, curly braces, to include a list of values. With discrete data, also our graph is going to have distinct and unique points as their values. Continuous data is the opposite. You're measuring something and is written as intervals. On a graph, you would see it as a solid line, and a solid line includes every value in between its endpoints. So that's why we use intervals. This can vary from dealing with our x value being between two numbers or our y value, depending on if we're talking about domain and range. And any combination or individual section, I can have it to where it is just less than, if it's just less than, or if it's just greater than, and of course the combination of both. An example, a set of weights includes a 4-pound barbell and 6 pairs of weight plates. Each pair of plates weighs 20 pounds. If X pairs of plates are added to the barbell, the total weight of the barbell and plates in pounds can be represented by f of x equals 20x plus 4. 20 being the rate of us adding each pair of weight plates, and the 4 being our starting point, our y-intercept. Our question is asking, what is the range of the function of this situation? Now, range for us is our y value. So we are looking for what we get out of this expression when we have each set of weights added to it, and then when there is no weights added to it. So we can create a table and then solve this equation, or plug this into the calculator where it would already give us the equation or the table. This would follow the steps of our calculator our calculator tip, where we have y equals, and we would only have this one in there so that we can create our table. So we would only have y1. At 0, we would have 4 pounds. We would have just the bar. With one set of weight plates, one pair of weight plates, we would have a total of 24. 2 pairs of weight plates, we would have 44. 3 would be 64. 4 would be 84. Then to 104. And then the max amount of weight you can have with all the weight plates is 124 pounds. So in this case, our range being our y value can be 4, 24, 44, 64, 84, 104, and 124. A is referring to our x values, our domain. B matches up with our answer. D does not include all of the range, and C is only a portion of the domain. So in this case, just to make sure my answer was correct, I went through all of my options. This is a helpful tip because sometimes, depending on the question, you may have an answer that makes more sense so that you can go back and check your work to make sure you're doing it correctly. This question will pop up. It popped up at the beginning of the year, school year. It goes, what is the domain and range of f of x equals 20? Now in this case, it only tells us f of x, which is another form of y, is 20. So we know that our y value can only be 20. There is no other number that it can be. From this lesson and earlier on, we know that range is y. So in this case, we know that our range can only be a 20. So range does not work here. So A is out. B has the proper range. C has a domain as 20, but it says that the range is all real numbers greater than or equal to 20. We are only looking for the one that is 20. So C is also out. And then D says that it is 20. So our options are between B and D. Now in this case, we have an equation that does not have the x variable, which is our domain. So that means that domain can technically be any value. There is no limit to what it can be. I could say domain was 0, or x value is 0. I could say x value was 1,000. It does not change the fact that y value is going to be 20. So I know that there's no limit to it, and this one sets a limit. All real numbers works. It means anything is possible, so that D is my correct answer. Example 5 says the graph of part of linear function g is shown on the grid. So this is part of the linear function g. Which inequality best represents the domain of the part shown? So in this case, we need to know that domain is referring to our x variable. Part of your test tips is understanding what you're looking for and compare it to your answer choices. In this case, only f and g are referring to our x values, our domain. H and j are referring to g of x, which would be our y values, our range. So we can already eliminate h and j before I even look at the graph in its entirety. With domain now, we know that we are dealing with the x values. It reaches over to an x value of -9 and a x value max of 2, which both include. What is different is the symbols that they're using. This is to understand that open circles just mean greater than or less than. It does not include. Whereas the open circle, or filled circle, I'm sorry, where the filled circle includes the value. This is where we have the equals or equal to symbols. So looking at this, at -9, we do not include. And at 2, we include. So now we can see that -9 is not included and 2 is included. So F is my answer. Going on to the last two problems, we enter literal equations. Literal equations have been one of the more difficult portions of our lessons, but we just need to understand that like terms can be combined, whereas terms with a different variable and power, or no variable at all, cannot be put together. They cannot be combined. So with that idea in mind, looking at number 6, it says, which of the following is equivalent to 6x minus 3y equals 12? The first thing you want to notice is that every one of your problems or answers says y equals. So it's letting us know what we would need to solve for with our equation. I need to solve for y. The first thing I want to do is get rid of my x term. In order to do this, to get rid of it, I need to subtract 6x. But just like normal, I cannot subtract just from one side, so I need to subtract 6x from the other side as well. When I refer to the other side, I am referring to the other expression. I kept it balanced by having a negative 6x term on both the left and right expression. Get the consistent color tone that I always have for work that is being added. Now after I add these terms to it, the 6x minus 6x cancels out, and it leaves us with the negative 3y. Equals, now this next part, 12 and negative 6x are not like terms. So just like the start where 6x was a separate term from our y term, we're going to do the same with 12 and 6x, negative 6x. Negative 6x plus 12. Now, the reason why I put the x term first is 1, that's where it consistently is going to go. And 2, that way it matches up with my answers. Now, we're not done yet. We still have the coefficient that we need to get rid of. And we do this by dividing the entire equation, both sides, by the coefficient. Oops, did not need that underline. There we go. Now in this case, we divide by the negative 3. It leaves us with 1y, which is just y. Equals this negative 6 divided by the negative 3 becomes a positive 2x. Oops. Positive 2x. And then our 12, positive 12, divided by a negative 3 becomes a negative 4. So to kind of line this up a little bit better, once we divide all terms, everything by negative 3, we get y equals 2x. So with this portion, 2x, I can cancel out c, minus 4. The minus 4 is the same between these two, but b has a negative 2. So we know that is incorrect, so A is my answer. Now we can do the same process on the next problem. Yet again, I want to make sure that I eliminate my x term as each one of my answer choices says y equals. I know I'm solving for y. Gotta refix my settings now. So I'm going to subtract 5x from both sides. This will leave me with the negative 2y equals, yet again, 20 and negative 5x are separate, unique terms, so I cannot combine them. So I'll be left with negative 5x plus 20. Now this time, when I divide by the negative 2, the coefficient, if I get everything set up, when I divide by the negative 2, the coefficient, you will get y equals negative 5 divided by negative 2 would be a decimal. As you can see, we do not have a decimal for our slope, our coefficient of x, so we need to leave it in fraction form. This would become a positive 5 over 2 times x. And then our last piece, positive 20 divided by a negative 2 would become a negative 10. So now that I've completely simplified this, I can check out my work. It says y equals positive 5 halves x. So anything that does not have a positive 5 half x, I can eliminate. And then it says plus 10. Or I'm sorry, it does not say plus 10. It says minus 10. So with minus 10, B matches, whereas D is a plus 10. So in this case, we eliminated C and A because of the negative slopes, and we eliminated D because it had the plus 10 instead of the negative 10. So that's the end of our review.